Hello guys, so this is lead code questions and today we are going to understand the today questions, right? So today questions we have 279 of a perfect square, and in which we are going to understand what perfect square question is. So given a integer, it is saying that we have already given an integer, right? Let's understand here. Okay, we have given already integer n, and we have to return the list number of perfect square number that sum to n. What we have to do, we have given number n and we have to return the least number of perfect square, right? Number of least, right? From you can see number of least perfect square number, we have to return that sum to n, okay. Let's understand how. Like, see, we have here given n, right, as integer. Okay, so n is the first example we have given n is 12, and we have to find the perfect square. So what are the perfect square? The least number, right? The least number that can be sum, and it will give the perfect square. Okay, so perfect square example we have 1, 4, 9 and 16. Correct? What, how many we have? 1, 4, 9 and 16 are perfect square, while saying 3 and 11 are not a perfect square number. Okay, so here, like 12, it is saying 12 is perfect square number. And how we have to calculate? We are calculating like three things. We are using how we will do that. Either we will go with 1, right, and then we will use 4. Okay, 4 and 1 is 5, and 9, if we will add 9, how many it will have? 14 we have, right? That is not good. Okay, if we will go with 9 and 13, so it will be 13, right? So what I will do, we will not write here 1, we will write 1, and uh, what we can say, the 9, we will use here 4, and we will use here 4. Correct? So now the you can add these three. Now you can add these three, and you can say that this is the perfect square, right? Now 4 plus 4 plus 4, what we have to do, we just have to add this 4 plus 4, and it will be 12. Now if the case we have, what we have case, we have 13, right? So if we will go with 1, right, it will not work. If we'll go with 4 and 9, right, so you can see, when I will add these only two, right, 9 and 4 is 13, so we do not require this one. Correct? So 4 plus 9 is what perfect square is giving. So total number is 2 here, right, and here 3. So the total output you can see here 2, and here we have 3. Correct? I think you understood now. So always we have given n, which is an integer number, and what we have to return, we have to return least number, right? Least number of a perfect square numbers, right, square, and that sum to n, that will give you the return value that we will enter. Now how many approaches we have to solve this problem? So we have multiple problem, that is multiple solutions we have, in which we have approach 1 is saying brute force, that will give you the time limit exceeded. So that is not required, but we will understand what the question is saying. Next we have dynamic programming approach 2, in which we will understand how to add. We have already one program already in our expert idea, where you can see how we have developed, but I will go through the dynamic programming 2, and we will understand how to develop it. Next we have next program we have approach 3 for the greedy innovation, right, and we will understand the concept. Approach 4 will go with greedy plus BFS, breadth first search, and we will understand through the node also. And the last one is the mathematical approach, we will understand that also. Okay, so let's go and understand. So approach first is saying brute force enumeration, in which we will get time a limit exceeded. But what you can understand through the intuition, what is the intuition of the program is this. So the intuition behind this program is the problem is asked to find the least number, right? What we have to find? The least number of a square numbers that can sum up to given number. So we could refresh the program as well, and we can say that given list of square number, given a list of a square number, right? Given a list of a square number and a positive integer. What is saying? We have given a list of a square number and a given positive number, right? Given positive number, that is called n. Okay. One is asked to find the combination of square number, right? Number, and that sum up to n. That will give you the value of n. Okay. The combination should contain at least least number among the all possible solutions, right? What are the combinations we have? We will get all the least number. Combination can be the higher number, but we have to find the least number, small number. One could reuse the square number in combination. Sorry. Okay. So from the narrative of the problem, it seems to be combinations problem, right? What is, we can take as a combinational problem, right? And we can say this is a combinational problem, right? Because we have multiple solutions, we have multiple sum in which we have to find the least one, right? The least number has been used in the combinations problem to solve to sum the value, and that we have to return, right? To which an intuition would be the brute enumeration, right? With brute force enumeration. So that is, I think, not required to explain much more. I think you have understood now. So where we enumeration all possible combinations we have, and we have to find the minimal one, right? We have multiple combinations we have, but we will find what we will find. We will find the minimal we have, that we will find minimal one. Okay. So if the formula is here, as you can see here, formula, if we will we could formulate the problem like what? We will take mean square, right? Yeah, number square, we will take the number square of the number, and we will calculate. How we will calculate? We will pass mean, and that will be num square n minus k plus 1, right? So it will give like k, where is k is the square number. Okay. And sorry, and n we will take as a square number, and a square number that we will have to find, but k is the square numbers, right? We will take a square number size 1, right? A square number is 1, and then 4, then 9, and what the number was? 12, I think, right? 16, remember. So these are the square number. K is the square numbers, right? K is the square numbers, and n is the number that we are going to find out, right? So if we are talking about 12 here, n is 12, right? N is 12. So the mean function will be the same, and n will be what? We will take n is 12 minus will go 1, right? For the first n, right? This first square number will go, okay, and plus 1, right? And then plus 1. Similarly, we will go with this will be the remain same, and next time it will come as 12 minus 4, right? And the first one will be remain same. Next it will come 12 minus 9. Next it will come 12 minus 16, right? 12 minus 16 you can take. Like this you can do that, and this is the formula we can use that, right? So, and in that all the solutions we have, that will get the minimum one, right? Because we have to write down. So one can translate into a recursive solution literally. So this can be that one. So this is the Python code. You can understand, you can pause it, and you can understand if you are aware of the Python though. Okay. So we are not going to do this because the time limit exits. But let's move to the next approach. We have dynamic programming. Okay, so in the dynamic programming, what we have to do, we have to understand the intuition, the reason why it is fail with the brute force approach, because it is simply we recalculate the subproblem. What we used to be, we are recalculating multiple times, we are doing recalculation, the same problem we are recalculating over and over. However, the formula that we derived from its still valuable, right? The whatever the formula we have valuable, and we need all we need is a better way to implement the formula, right? So we have already understood this function, right? How this function we have to enter, how we will put the n value and k value, right? One might notice that the problem is similar to the Fibonacci series, right? The Fibonacci problem, right? We used to pass the last two value, then we will add to the next, then it will come, right? The sequence we used to generate. Judging from the formula and like the Fibonacci, we have a several more efficiency way to recalculate the solution other than the simple recursion. Okay, so one of the idea is to solve the stack overflow issue is a recursion is applied to dynamic progress. Okay, because if we will if we will implement the last approach, that is this formula, right? So what will happen, we will get the stack overflow issue, right? We will get stack overflow in the recursion because we are recalculating multiple times the same solution, same sub problems over and over. So what we have to do here, we will apply here dynamic programming. What we will do, we will apply dynamic programming, and this dynamic programming DP technique, which is built upon the idea of reusing idea of reusing the result, right? If we have already calculated some sub problems or sub solution, we will store somewhere, and then we will, if it is required, we do not need to recalculate, we will reuse that. Okay, so the DP technique, which is built upon the idea of reusing the result of intermediate sub problem to recalculate the final solution, as you know, everyone, right? So if you don't know, this was the recap. Like, we have already calculated, like some value we have already calculated, so intermediate sub problem, you can say, sub solution you can say, and we will store somewhere. And if we require again, we will not going to recalculate, we will collect from the there, right? Because we have already calculated. To recalculate the value of num sub problem, right? Num sub square, first we need to recalculate all the value before. Okay, all the value before n, means if we are talking about the value that we are going to calculate, the num square we have to find, first we need to calculate all the values before n, right? Like if we are talking about 12, so we have to calculate 1 to what, 11, all the value we have to calculate and we have to store somewhere, correct? So when the 12 will come, the all the sub problem already has been calculated, right? And we have to just sum up, and then the final solution will be there. So it will be very easy to calculate all the values, right? So we need to first calculate all the values from before n, you can say before n. The number square n minus k, where the k is a square number, like 1, 4, 9, 11, and 1, 4, 9 and 16, right? If we already kept the solution, right, for number n minus k in somewhere, then we not need to resort the recursive calculation prevent the stack overflow, right? We will do that. It means we have calculated and we will store somewhere. If we need, then we will reuse, and the recursion will reuse the stored value. Next, so it is saying based on the intuition, what it is saying, based on intuition, based on intuition, what we have, we could implement the DP solution in the following step. What? So as for almost all DP solution, right, if we know, if in all DP solution what we used to do, we first create an array DP, right? We always create one DP, or either for one dimension or multiple dimension, and we hold the value of intermediate sub solution, correct? We used to hold the value of intermediate sub problems, sub solutions into the DP. That is either a one dimension or two dimension. It depends on the solution, what type of solution we have to do. So as well as the final solution, which is usually the last element in the sub array, in the array, you can say. Note that it is saying, note that we create a fictional element dp of 0, right? Dp of 0 equal to 0 to simplify the logic. So make sure we will create first a dp, one dimensional, two dimensional, whatever is required, and then we will hold the intermediate sub problems sub solution, you can say, and then we will create a fictional element dp equal to 0 to simplify the logic, correct? 3 points we have to take care, which helps in the case that the remainder n minus k happen to the square number, right? So as an additional preparation steps come, we pre-calculate the list of square number, right? We pre-calculate the we used to pre-calculate, okay, all our square numbers, right? A list of a square number. So that we will take as a what, a square num, okay, and which is less than the given number, sorry, right, which is less than the given number. And then our main step, we then loop from what, 1 to n to recalculate, right? To recalculate we will do, right? And then num of a square at least iteration, right? For each number we will loop each for to calculate the number for each number from 1 to n, right? What we have to do, we have to make a loop, and then at each iteration we keep the result num of I in dp of I, right? We will store each value while reusing the previous result stored in the array. At the end of the loop, then we return the last element in the array as the result of the solution, correct? So let's understand how to illustrate, how to calculate the result of numbers nums 4 and nums 5, which correspond to dp4 and dp5, right? Or either you can pause here and you can try by your own, in which what the approach should be here. The first you have to take a dp array, one dimensional or two dimensional, right, whatever required, and then you have to hold all the values of values of intermediate sub solutions, and then we have to create one fictional element, that is dp equal to 0, to simplify the logic actually. And in that case the remainder n minus k happen to be a square number. As an additional preparation steps, we pre-calculate a list of square numbers that we can take as a square numbers, right? And which is less than the given number, right? So as a main step go on, first we have to loop 1 to n, right? Whatever the number we will take, in our example we are taking 12, so we will start with 1 to 12. To calculate the solution for each step, what we have to do, we will calculate num of I, and for each step we will, after the calculation, we will store somewhere I, right? Num square I we will store in dp of I, right? And in the last what we will do, we will return the previous element of the array as a result of the solution, right? So this is the way we will do that. And let's understand one more time. So as you can see here, the illustration we have, so dp of 4 we are calculating dp of 4 minus 1 plus 1, and dp of 4 minus 4 plus 1 equal to 1, right? How we are doing, dp of 4 minus 4 is what, 0, and dp of 4 minus 1 is what, 3, and then if we will calculate minimum, whatever the minimum value we have here, that will come into dp of 4, correct? In this way we have to store the data, okay? Another way, we have dp of 5. We are taking minimum of dp 5 minus 1 plus dp what dp 5 minus 1 here you can see here, and dp 5 minus 1 plus 1 equal to 2. How? So dp 5 minus 1 is already calculated, right? The index we have 4, right? Already we have, and another what we have, plus 1 we have. Then dp 5 minus 1 plus 1, right? So dp 5 minus 1 is 1, index 1, right? That value we have 1. So 1 plus 1 is 2. So the mean value is what? That the 5 comma 2 is 2, right? In this way we have stored dp of 5 equal to 2, correct? Let's go to understand the code. Okay, so we have class here, solution. We are taking class solution here, and we will take num square. Already we have here, right? Num square. We will take integer n. So first approach, I told you to create one dp one dimensional array we can take right here, and then we will fill some sample value we will add, right? The max integer value we are putting here, right? And in and the bottom case is that we are going to take uh, a case we are going to take a bottom case, we are our base case you can say dp of 0 equal to 0, right? From where we will begin, we will pre-calculate all the square number from 0 to n, 1 to n. For that, what we have to do, we have to make a square, a loop, right? I equal to 1 to I is less than max square index. So how we will find the max square number? We have to do some math here. Math dot a square of n plus 1, correct? So this is the max value. Either way, what we can do, either you can put here 12, right? Sorry, n is less than equal to, you can do that, right? So we are taking math dot square of n plus 1, and we will calculate the max square index. Okay, int a square num of I, a square number of we are taking another array right here, a square num, and we will take max square index here. So we will store all the square number of I plus I into I. Okay, we'll calculate I into I and we'll store here. Next time, when the loop will start from for I equal to 1 to n, and we will make inside another loop s equal to 1 to s is less than max square index s plus plus, right? S plus plus s. Then I should be less than equal to less than num of si, and then it will break. We have to break. Otherwise, what we will do? We will store dp of I, math dot mean dp of I minus a square number of I plus 1, and then we have to do dp of n, right? So understand how we have did here. First here we have taken dp. First we have taken dp n plus 1, correct? So the dp value we have, size we have taken this value plus 1. The value we are going to calculate plus 1 means if we are putting 12, means the dp have size what? Dp has size 30 now. Okay, next we are storing, we have taken arrays dot fill, and the dp is already filled all the data, right? We have started with the max value, and some value we have stored in the whole array. The index first we have at index 0, we are taking as a 0 value. We are removing, we are taking only 0 for the bottom case. Now we have to pre-calculate the square number, right, for all the value, right? So 12 square root, what is the square root of 12, right? So we have to find the square root of 12. Okay, and that plus 1, whatever the value will come, we will store into what? Into this one, correct? And then we that will be our square index, correct? That will be our square index. Next, if we will go to the square number, what is the square numbers? So max length should be max plus square max square index, right? Maximum square index will be the square number index. We are going to calculate all the square number and we'll store here in num. We'll start from I once to I into I. We'll keep here. Now we will take for loop and we will store the loop, the value, right? So I will start with 1 to n and then s equal to 1 and s will less than max square index plus plus. If I value is less than the square number s, then it will break, otherwise we will store the dp here, and then that we will calculate dp of I and I minus the other value, right? And whatever the value will come, that the minimum value will store into dp, and that dp value we have to return. In this way we will go to the next approach, greedy innovation.